In this problem, we're told that we have a certain set of cash flows. So the cash flow at time 0 is smaller than 0. All the subsequent cash flows, C1, C2, and it keeps on going, are all positive. And then we're also given the condition that the sum of all these cash flows is larger than 0. And then under these conditions, we want to prove that there exists a solution for the yield equation. So there exists an I such that this whole expression here is equal to 0. So how do we prove that? So first of all, let's just write out what we're trying to prove. So we're trying to prove that this function here has a solution for when this whole function is equal to 0. So how do we prove this? So first of all, let us just draw a graph. So this will be pi, and then this will be I. And then let us just imagine what will happen if v is equal to 0. So v equal to 0, that means 1 over 1 plus I is equal to 0. So that is the case when I is tending to infinity. So I know this is an unrealistic case, but let us just entertain this thought for the time being. So when I tends to infinity, so that means when, for this graph, when it keeps on going all the way to infinity, and that means when v is equal to 0, what is this expression equal to? So if you sum this up, you see that when v is equal to 0, all the subsequent payments, C1, C2, C3, they're all multiplied by V1, V2, V3, right? And then all of these V's will be equal to 0, so all the payments of C1, C2, and C3 will essentially be cancelled out. So all these subsequent payments, we can all disregard all these, because in our case, when I is tending to infinity, V is equal to 0, and under this condition, all these terms will be equal to 0. So all we're going to be left with is C0, which we know is smaller than 0, because this is one of the given conditions of the problem. So we know that when I is tending to infinity, the function over here is over somewhere here in the negative region. So this is what we know from this condition. So when we consider the case where I tends to infinity. So another case we can consider is when v is equal to 1. So let us just get rid of this for now. So when v is equal to 1, so that corresponds to the case where I is equal to 0. So I is equal to 0. And then if you substitute v equal to 1 into this equation, this immediately becomes, so this expression becomes just the sum of all cash flows. And then we're also given the condition that the sum of all cash flows is larger than 0. So you can imagine it being somewhere over here, the function. So when v is equal to 1, I is equal to 0. And what exactly does this tell us? And then because this is essentially just a polynomial equation, right, for I, and so we can actually deduce that this whole function is actually continuous. And then by the intermediate value theorem, which you've learned in Math 1821, so this is just calling on your knowledge from your math courses, you know that I don't care how this function behaves in the middle, because this point over here is above 0, this point over here is below 0. In the region in between, there must be a point where the function must cross the x-axis in order to reach the bottom here, because it's continuous. And so that is why there must be an I such that the yield equation is equal to 0. So by the math intermediate value theorem, we can actually prove that prove the claim in the questions that given the conditions, we always know that the yield equation always has a solution. So there's always a corresponding I. So that is how you prove it, by the intermediate value theorem. And if you want to ask about the significance of this problem, you can think of it like this. So the C0 in this problem, which is negative, you can think of this like an initial investment. So perhaps you're buying a store. So you're paying a lot of money to buy a store. And once you set up a store, you can start to earn money. And the C1, C2 would be the revenue of each year. So this is like a model of the cash flow of maybe like a business project. And then we know that under these conditions, we can always find an I, and then in that case, the I would be the rate of return for that particular business venture. So this is like a theoretical treatment of this kind of cash flow modeling. So this is the significance of this problem.